Greetings. Today I'm going to demonstrate how to set up this network. I'm not going to go through every step, but first off we're going to talk about how to configure the initial IP network addressing plan so that we can implement this network. Today we're going over the first step, which is to develop the IPv4 addressing scheme to fit this network. In this particular example, we are trying to connect our branch office, which includes this branch router, these two switches, and a couple of PCs, up to a corporate network. The corporate network has already been established and set up. We simply need to take an IP configuration given us to by the corporate network administrators and set up our own local network. Before we can actually begin to program these devices and connect the network, we must create an IPv4 address plan. To do so, I'm going to show that plan using this drawing application. In this particular plan, the network administrators have given us the following address: 172.22.4.0 with a /24. So although this was originally a /16, obviously the corporate network administrators have taken this and they have extended the mask and therefore have created multiple subnets, and we've been assigned one of them, which is 172.22.4.0. We would like to take this and assign it to our network in the most appropriate fashion. We must meet certain requirements while we're doing this. We require meeting a sales subnet, and the sales subnet will have up to 25 hosts per subnet. The support subnet will have up to 6 hosts per subnet. The instructions for this particular assignment have asked us to go ahead and create a variable length subnet mask plan to assign different subnet masks to these two subnets based on the number of things required. We've been asked to fill out a table for subnet A and for subnet B. So for sales subnet and support subnet. So that is what we're going to do. First off, whenever you create a VLSM plan, the first thing to do on the VLSM plan is to be able to create a plan that meets these requirements. To do so, the first thing you do is you identify the largest subnet. So in this case, the sales subnet is the largest subnet. So the sales subnet being the largest, we now must create a plan to meet that. So if we are currently on a /24, that means we have a subnet mask that looks like this. So that's our existing subnet mask. To get to a subnet mask that can support 25 hosts per subnet, we have to determine how many hosts bits are required in the subnet mask here in the host field, in the host portion of this mask, in order to accommodate 25 hosts per subnet. To figure this out, we can do some simple just powers of 2. So we know that 2 to the power of 3 is 8, so that's not going to be enough. So we need more than 3 bits in the host field. 2 to the power of 4 is 16. That's not enough. So just 4 won't work. 2 to the power of 5 is 32. So that is what we need. So we must have 5 host bits left over in order to accommodate a subnet with 25 hosts per subnet. So in this case, we've decided to extend our mask to a /27. So /24 to /27. So our first subnet, our sales subnet, this is going to be called subnet A. Subnet A, or sales, will have, we'll extend by 3 bits. We're going to extend by 3 bits. So we're going to go from a /24 to a /27. That will accommodate our first subnet. We know that our new mask will be 255.255.255, and we can of course convert this last octet to decimal, and that would be 224. So our new subnet mask will be 255.255.255.224. We know that we are going to have more than 25 hosts per subnet. In fact, we figured out there are 32 available IPs per subnet. So we know that there's going to be 32 minus the network address and the broadcast address will leave us with 30 possible hosts in this subnet. And that will meet our requirements because that's more than 25. So a /27 will work for sales. So now the question becomes, what are the network IDs for this subnet? So the first one is going to be 172.22.4.0. And we know that because we always start with the first one. The next one is going to go up in increments of the number of host bits. So in this case, we have 32 possible IPs per subnet. So because we have 32, we're going to go up in increments of 32. So 172.22.4.32. And we know that there's going to be 8 of these because we calculated right here that 2 to the power of 3, because we borrowed 3 bits, is 8. So we know there's going to be 8 subnets created. So let's go ahead and write those down real quick. Right? So all we do is add 32 every time. So that's what I'm doing. I'm just writing out . So this should be the number 0, the number 1, 2, 3, 4, 5, 6, and 7 for a total of 8 subnets. So the question on the exercise, on the instructions that I sent out, we need to then have 172.22. It said to go ahead and use the number 0 subnet. So we're going to use this one for subnet A. So we know that the network ID, so the ID for the sales subnet will be 172.22.4.0. Pretty simple. We know that the broadcast address is the last available IP in this range. So that would be 172.22.4.31. So I know that the broadcast ID is going to be 172.22.4.31. I also know that the first available IP, so the first IP available to me is going to be 172.22.4.1, and my last IP possible is 172.22.4. And it would be not 31 because that's a broadcast ID. It would be .30. So those are the answers that you need to fill out the table. That all the information we need for subnet A, which will be the sales subnet. This will be the network that we use to basically add to the sales subnet that you see up here. So the sales subnet will be assigned this information that we've just diagrammed here. We're now ready to take out and go to the next level in our VLSM plan in order to plan out subnet B, or what is called the support subnet. Now, we know that subnet B only requires 6 IPs per subnet. So we don't need to go as far with, we don't need to use as many bits in the host field in this case. So we're going to use fewer bits in the host field in this particular case. So what we're going to do is we're going to take this network number 1 right here, and this is going to become the basis for subnet B. So this is our, so 172.22.4.32 on a /27 is what we're starting with. And this is going to become the basis for subnet B, or the support subnet. Now, a /27 looks like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Well, in order to reduce the number of hosts that I'm wasting with a /27, if I'm only going to need 6, I need to figure out how many host bits are going to survive over here. Well, 2 to the power of 3 is 8, and that's basically what I need. So I need these 3 bits right here to remain in the host field. These 2 can now change. I can now extend my mask to cover those 2. So I'm going to go from a /27 to a /29. So the answer to take the second table in your exercise, the subnet A versus the subnet B exercise, subnet B will now be a /29. We basically extended this by 2 bits. Our new mask is going to look like this, which is basically a /29. And that is basically, if you write this out in decimal, 255.255.255.248. So that is our new subnet mask, 255.255.255.248. We know that we have 2 to the power of 3 in the host field, which is 8, minus the network ID and broadcast ID is 6. So we know that there are 6 hosts per subnet in this particular situation, which is exactly what we needed for the support subnet. We know that the first available IP address is going to be 172.22.4.32. And we know that we're going to have 2 to the power of 2, or 4. We know that we created 4 subnets. And we know that they're going to go up in increments of 8. So we know the next one will be 172.22.4.40. And then the next one will be 172.22.4.48. And the next one, 172.22.4. And then you'll have to do a little bit of math in your head there. You basically, all you have to do is go up in increments of 8. 32 plus 8 is 40. 40 plus 8 is 48. And 48 plus 8 is 56. These are the 4 subnets created by extending by 2 bits. This will be the 0 subnet, the 1, the 2, and the 3. We are going to use the 0 subnet because the instructions told us to always use the 0 subnet. So our network ID, our network ID for this one is going to be 172.22.4.32. It now wants to know what our broadcast ID is. Our broadcast ID will be the last available IP in this block, which is 39. So the broadcast ID is 172.22.4.39. That's the broadcast ID. The first available host IP address in this case, so the first available is 172.22.4.33. The last available IP address then would be 172.22.4, and not 39 because that's a broadcast ID, but 38. So that gives you all the information to fill out the second chart in the instructions on subnet B, or what is called the support subnet. So of course this particular network right here, the support staff subnet, would be assigned all of that information that we just created here for subnet B. So we've now identified all of the network details for the sales and the support subnets. Notice that this is variable length subnet masks because sales on the subnet A sales network has a /27 and the support subnet has a /29. Okay, let's go through, let's just talk about what IP addresses we're going to assign to what devices. So the instructions want us to assign PC1 an IP address, a mask, and an IP address, a subnet mask, and a gateway. Well, we got to look at this, so we got to go over here and we're going to take a look at PC1. PC1 sits in the sales subnet, and we've decided to assign sales subnet the 172.22.4.0 network on a /27. And the instruction said to give the PC the second available IP address and the router the first available. So the IP for PC1 would be 172.22.4.2 because .1 will be assigned to the router and .2 will be assigned to the PC. The subnet mask will simply be the subnet mask we defined here. And so we're going to go ahead and write that down. The subnet mask, I'll just put that here, subnet mask will be 255.255.255.224. The default gateway will be the router's IP, which will be the first available IP address in your subnet. So it'll be 22.4.1. So this is the information for the PC that will be needed in the diagram that you're going to be completing. PC2, let's go ahead and take a look at that. PC2 sits in the support staff subnet. So because PC2 is in there, we're going to assign them out of the 172.22.4.32 subnet. So it's going to be the IP for PC2 will be 172.22.4. It's not going to be 32 because that's the network ID. It's not going to be 33 because that is going to be assigned to the router. The second available will be 34. So that'll be the IP address that we assign is 34. Okay. All right, so and now we need to know what the subnet mask. Well, the subnet mask is right here. That's for the support subnet. So the subnet mask will be 255.255.255.248. And the gateway will be the first available IP in this subnet. So the default gateway will be 172.22.4.33 because that's the first available IP address. This is now the information that we are going to assign to PC2 on our diagram. Now it also asks us to figure out what the router. So it wants to know router G0/0. So just to show you where that is, on the diagram, G0/0 is the interface on branch RT that will be connecting to the sales switch. So because that's going to be on the sales subnet, we need to assign an IP address and a mask in the sales subnet. So that's pretty easy actually. The IP will be 172.22 172.4.1 with a mask of 255.255.255.224. And notice that the default gateway is the router in this case. So PC1's default gateway address is the router's interface IP. So then we also have the router RT's G0/1 interface, which its IP will be on the support network. So it'll be 172.22.4.33. Notice that the default gateway of PC2 is also the IP of interface 0/1. Its subnet mask will be the same as PC2. It'll be 255.255.255.248. Those are the router interfaces that you'll be assigning to the devices inside the packet tracer. The next thing it wants to do is to assign an IP address. In this case, it wanted you to assign the last available IP address to the switch. So the sales SW1 switch resides, and I'll show you, it resides in the sales subnet. So we're going to assign it the IP, and it wanted the last available IP in the range, which is 172.22.4. Now it's not 31 because 31 is the broadcast IP. It needs to be the last available IP, which is 4.30. So 4.30, and the subnet mask is the same as everybody else in that subnet, 255.255.225.224. And the default gateway will be the router's IP, which we now know as 172.22.4.1. Now the support SW switch resides on the support network. Its IP will be the last available IP in that network, which will be 172.22.4.38. And its mask is 255.255.255.248, and it will use the same, it'll use the router as its gateway of 172.22.4.33. That's it. That's how you figure out the IP addressing for this particular network that you see before you.